Blocked. It won't go off now. Okay. This is group 5 with just a normal day. We will be going over the normal distribution curve along with going over its characteristics and using the empirical rule in order to figure out the z-score that connects to it. My name is Dava Pound, and I will be starting with, and this is Bianca Porter. And I will be going over its characteristics and
the connection.
And the connection. Go ahead. And forgive me, I'm having to use my phone. Okay. So, normal distribution. The characteristics that follow, it has 4 characteristics, and with the normal curve, it will always be symmetrical. It will have at least one mode or more. It will be asymptotic, meaning the curve never touches the x-axis or the line, and the mean, median, and mode are always equal. Some connections in regards to finding the area underneath the curve. We will be including also a z-score table, which I actually did not post. So finding out the area, you're going to take any value of x, and you will subtract it from the mean, and then you will divide that by the standard deviation. As you can see below, I did a problem getting a 6 and then transforming it into a decimal, which then go into the z-score table, finding that standard deviation and the decimal that goes along with it, and remembering that beside the mean on each side are all halves, so you would add it to that z-score. And those are my references, and I will now be passing it on to my partner Bianca, who will be going over the empirical rule and how to use the z-score table.
Okay. You can see that, right?
Yes.
Okay. I am Bianca Porter, and I am just going more into detail about the empirical rule and how to calculate percentages and how to get the z-scores. I will show more examples. Okay, so the empirical rule states that for a normal distribution, nearly all of the data will fall within 3 standard deviations of the mean. The empirical rule can be broken down into 3 parts, which is the 68%, which is usually in the middle, which is the mean, 95%, and 99.7%. And what I had here was an example of the empirical rule and percentages. It was about the lifetime of certain types of light bulbs and how they are normally distributed. The mean life of 400 hours and the standard deviation is 75 hours. For a group of 5,000 light bulbs, how many are expected to last each of the following times? So right here where it says A between 325 hours and 475 hours, we look at the bell-shaped curve between 325 hours and 475 hours, 68, that's right in the middle. So 68% of the light bulbs are expected to last between 325 and 475 hours. This means that 5,000 times 0.68 equals 3,400 light bulbs are expected to last between 325 and 475 hours. And so on and so forth with the rest of the problems and how to calculate percentages using the empirical rule. Now I will be showing you guys about the z-score and how to find it, and also the z. Let me see if I can get that. Can you see that? You can see that, right?
Yeah.
Okay. All right. So let me zoom in on this part because I kind of like wrote in. You got to excuse my handwriting because it's horrible. Okay,
It's on
so
computer.
I kind of explained the z-scores, right? I took a problem out of the math book, and this is what I came up with, and I kind of got a table describing or how to get the z-score. Okay, so let me break this down. Okay. All right, so this question says, suppose that IQ scores had a bell-shaped distribution with a mean of 100 and the standard deviation of 15. What percentage of people should have an IQ score between 85 and 115? So right here, I put 85, and then 115, I put as x2, and right here is 100 for the mean. The mean is always going to be in the middle.
Mm-hmm.
So to find the z-score, what I did was oh my God, you have to excuse this, okay? Z equals x minus the mean divided by the standard deviation. So you would get x1 minus the mean, which is 100, and you divide it by 15, the standard deviation. And you'd be like, negative 15 divided by 15 is negative 1.00. So this number right here, negative 1.00, how you would find the z-score for that is you would get, or go to the table, and how to find the z-score is to, even if the number is negative or positive, you still will go to the number because it's always going to be the same answer. In this case, it would be 1.0. You would find that on the table, and it will give you 0.3413. So what that means is that the area from x1 to 100 is 0.3413, and that is how you would find the z-code. I mean, I say z-code, z-score for the area.
Or 34.13%.
Yes. All right, and that's how you would get the z-score for that.
I hope everyone liked our presentation. And this again is group 5 with Just a Normal Day. And I'm Deva Pound.
And I'm Bianca Porter.
And we want to say good night.